there will be a situation where the quadratic equation given to us is not factorizable. Okay, you cannot factorize the quadratic equation. So when we have this situation, the alternative method that we can use is to do the completing the square. Okay, completing the square, there is a formula for completing the square, but I don't really remember the formula. So what do I normally do is I just write down this equation. And I always start by taking the s plus with the 2 and divide by 2. So the 2 that I take here is actually this one, this one. Okay? And then I have square here. So that will give me s plus 1 square. And if I do the expansion, I have s square plus 2s plus 1. So I can compare left and right here. I have s square, I have s square. I have 2s, I have 2s. I have 17, I don't have 17 here. I only have 1. So how do I make it a 17 is I need to plus this one with 16. So if at the bottom here I plus 16, then this is what I should have. So basically this is my completing the square equation. Okay, s plus 1 square plus 16. Therefore, I can simplify my equation to be like that. So when I compare this with the mapping that I have, I can see that this domain, it has s plus 1, but the domain that I have here is not yet s plus 1. So domain on the top and domain at the bottom is not the same. So what do I need to do is, first I have to change so that I have the same domain. So to have plus 1, then I have to add plus 1 here. But then I do minus 1 as well. So this one, if we have s plus 1 minus 1, basically this is s lah. Okay, if you add up s plus 1 minus 1, this is actually equal to s, which is also equal to the original equation. Okay, but I managed to obtain the same form of s plus 1 and s plus 1 here. So what do I do next? Simplify the equation. That will give me s plus 1 minus 2 minus 3 divided by this. So the inverse Laplace is given by this one . like this. So if we do the mapping, this is actually Fs minus A, which is equal to EAT FT. Same goes here lah, for both. Okay, for both equation here, same goes like that. So what I can do here is I can factorize out the exponent. This is the first shifting property. We have S minus A, so this one can be factorized out, so that we only have Fs here. So the Laplace inverse for Fs will give us Ft. So I will have 2 outside, E negative t. So my Laplace inverse now will only have S over S square plus 4 square. Minus with E negative, I can bring out the 5 out. Negative t. Laplace inverse for 1 over S squared plus 4 square. So this one, you can refer into the table. S over this is given by cos 40 minus with 5. This one, if you check into the table, it will be slightly different because we need to have 4 on the top. But what do we have is only 1. Therefore, we need to cancel the 4 by divide it with 4. So our Ft is given by this. Okay, so that is the final answer for our inverse. For our inverse transform, but this time we use completing the square method.